to talk about open source at scale. Now, what exactly do I mean by scale? Oh, here we go. There we are. So this is output from a program I wrote 3 years ago called npm top. And back when I first wrote it, so this program basically lists out npm by authors and how many packages they've published. So the top one right now is TJ Halliday with 529 packages. But when I first wrote this program 3 years ago, the top user, I think, was still TJ Halliday, but he only had something like 50 packages. So NPM has gotten really, really, really big. And that's great if you like open source and you like building software out of lots of tiny pieces that you can recombine like Legos. There I am in the list at number 2, but look at the long tail of that. There are, on this list alone, 6 people with over 300 packages, 13 with over 200 packages, and there are over 56 people on NPM right now who've published or maintain more than 100 packages. So people are maintaining a lot of software right now in this really modular way, and that's kind of what I mean by scale here. There's just a lot of small pieces that we can recombine and manipulate in really novel ways, and that's what all of my examples are going to be about. So in terms of like the scale that I personally experience, here's my open issues on all of my repos right now, 1,290 across about 600 GitHub repositories, and 370 pull requests. So it's really important for me operating at this kind of scale that I come up with a lot of nice practices for kind of managing this, because it can get to be a lot of overhead. So it's the first thing that I normally do. Uh-oh. That's weird. Let me just refresh. Let me refresh at that zoom level. Hopefully it will be better. Okay, well, it's weird. Anyways. Oh, that one's good. Okay, we'll go with that. So, anyways, so the first thing that I normally do is when I evaluate a pull request, here's a patch that I just got yesterday, actually, from someone on one of my repos. So I can't show you that GitHub page right now, but I can actually print out what the URL is. So that, okay, so here's that patch that I got from somebody. It's for one of my repos. In this case, it's for a module called Seaport that I wrote. So here, somebody sent a patch to help fix the unit tests, because I guess a patch recently landed and the unit test broke on Node 0.8. It worked fine in 0.10. But so here, this patch, someone has just added a little test for exiting the process on the test end because something was hanging up the event loop. So that's a pretty sensible patch, I think. So usually what I do when I want to merge something like this, it's getting kind of weird, is so normally I go on GitHub, there's like some pull request page. There are all of these ways that GitHub wants you to use GitHub that I think are really silly. Like they have their own command line tool, they have their own silly, like, click a button and then it shows you how to merge things on the command line. Those are really silly. What they've done that's really clever is if you take any pull request URL, you can append .patch on the end, and then you get a URL that you can pipe into this other module called getam, which is really cool. And you can even do things like three-way merges if you do getam-3. So this was a relic from back in, oh, hang on, I think I actually landed this one already. So there we go. Anyways, I think it landed. Yep. Close enough. Whoa. Oh, it's because I'm in the wrong directory. Ha. Sorry. Okay, cool. So here, I've just merged this pull request from this guy Eduardo, and now Seaport is using that patch. So I get a lot of these kinds of patches, and usually what I do after this point, after I've merged it, is I run the tests. So it's really good in your package.json to set up a scripts.test field, because then anyone who wants to test your module can just type npm test, and that'll run. And so here we're running the unit tests, and everything is going okay. So great, everything is okay. We can just make sure the exit code is correct. It is, and then we can tag that release. So in this case, I would go into the package.json. I would bump the minor version maybe. Whoops. Yeah. So make a commit for that. I forgot what it was already, even though I just saw it. Okay, so that is version 2.0.5. So I tagged it, and then I pushed to GitHub, and npm publish. So that's actually npm publishing right now, so through my browser. So there we go. That's kind of my normal flow for merging these pull requests, and I get a lot of them. It's really important for these things to be really small, and another really important thing for managing projects or longer term is that they should really be small and focused, and you don't want the feature set of any one particular project to grow too big, because then you invite a lot of contention over what your project does. So you get a lot of people fighting over the color of the bike shed, like paint it red, paint it orange, paint it yellow, and nobody actually arguing over the hard parts that are hard to argue about. But limiting the scope of your modules is really important, because it lets everybody have the same tools, and it lets everybody disagree where they think that's important. So this is a great quote that I read recently on this article from a person who does a lot of game development, and they were really upset with putting a lot of effort into a bunch of really big games, maybe only 2 games a year, and so instead they scrapped that, and they started pumping out maybe a game every 1 week or every 2 weeks. And I thought this quote was really great. So it does not matter how trivial or frivolous a project seems, everything you do adds to your body of work. I can't stress this enough. You're not just creating a bunch of small things, you're creating an ecosystem of projects. So what does an ecosystem look like? Oh, hang on, get to that in a moment. Here's another great piece of advice. If you have an idea for a module, you should build it as soon as possible, because that motivation can be really fleeting. So you should, once you have an idea, you should just go to town, spend only an hour or 2 building it, ideally, before you pump out the initial version, because your motivation might slip away, or you might try to do too many things and it might not work out. So it's really good to keep things really small and modular, because then you can finish them or get something out the door that other people can see and give you feedback on. And Dominic Tarr said this on IRC, I think a week ago. He was here last time. Somebody says, any good node modules for Cap and Proto? And then Dominic says, Macintosh, if you see a job that needs doing, it's your job. So here's what an ecosystem can look like. This is the DAP project, which is by Max Ogden. And those are all of the modules that DAP depends on, the entire dependency graph. It's including lots of things, some that I wrote, a lot of modules that a lot of other people wrote. And I think that's something that we should be striving towards, because now DAT has all of that functionality that all of those modules provide, but it doesn't have to worry about all of that itself. It can focus on doing its own thing, which is like data replication and those kinds of problems. So this is something that I've learned slowly as I've been adventuring my way through the lands of Node. So this became really apparent as I was building Browserify, because in the early versions, everything was not modular. It's ironic, because Browserify was intended to let people write very modular code, but it itself, before version 2, was not really modular at all. It was just a big ball of code. So in version 2, I had this crazy idea for this new pipeline that actually worked really well. It has 3 main components, and the middle one I've switched around a little bit, but this is basically how it still works. The first one is called moduledeps. The next one, and moduledeps basically just takes in a source file and recursively traverses it, but instead of outputting the final result, it outputs an intermediary JSON output. Insert module globals just looks for globals like process.nextTick or buffer or dir name and file name, that kind of thing, that are globals in Node.js. And then Browserpack takes that JSON input and spits out the final bundle file. So each of these pieces is really focused, and what's cool is you can write one of them and test it without having the other ones necessarily finished. So this was a really great way to prototype getting the final Browserify out the door, was just splitting it up into these little pieces. So first of all, if you haven't used Browserify or if you haven't used Node modules, here's basically how they work. So you start out with an entry file. An entry file is, it's where you start, where your code starts at. So here we'll just have a main.js. We'll load another module using this function called require that's available in Node for you automatically. If you want to use this kind of thing in the browser, then Browserify will compile all of your code so that it creates one big bundle file. So you can drop a single script tag into your page. So here we'll load a file called foo.js, and we'll just do something simple. We'll just console log foo of 5. Cool. So now in foo.js, we use this other thing called module.exports. Module.exports, instead of normally how the browser is, where you define a bunch of globals and maybe you concatenate all your scripts together, or you just don't do that and just have like 20 script tags or something. Module.exports lets you explicitly say what you want to export. So we can have private variables in this file, like up here. Whoops, caps lock is on. So you can have private variables and they stay private to this file. You don't have to worry about them leaking. But in this case, all we need to do is export a simple thing. So here I'll return n times 111 maybe. That's a good one. Okay, cool. So if I run main.js in Node, I get 555. That's simple. If I want to run this in a browser though, I can run Browserify main.js and give it -o, or just do a redirect on the shell and write to bundle.js. Actually, it's a good idea to also just see what that output looks like. So here I run Browserify main.js. We can see the main.js is in here, the console log part that we wrote before. And there's some boilerplate around it that was put in here automatically. And there's our foo.js. And basically, Browserify establishes mappings between all of the require calls in your file to internal module IDs with this really minimal, about 600 byte prelude function. So it's a really small amount of overhead, but with that, you can have all of the power of Node modules, and not just Node modules, but actually NPM modules. So let's see, something in our path. I think through will be in our path. Nope. I'll use this one. So not only can you use Browserify for your own internal modules, but you can use it to install things from NPM. Like here, oh wow, it actually worked. So we can install a module from NPM, put it into our require calls like normal, and now instead of just console log of foo, console log gamma of foo, but gammas can be pretty large. Maybe gamma of 5.2. So if we run that in Node, it's just an ordinary CommonJS module, so we can just run it. But if we run that in Browserify, then we get more code. This is from the Gamma module, which was automatically included into our scripts. But like I mentioned before in the previous slide, Browserify internally is using moduledeps and insert module globals in Browserpack. So let's see what Browserify is actually doing by running those ourselves. So we can invoke moduledeps by just doing moduledeps. I don't know why it does that. Moduledeps main.js, and it outputs this JSON blob. So this is basically a big array, and every object in that array maps to a file. So here, this one maps to food.js, and it has the source inline, and this one maps to the gamma module, and it has the source inline. And what's cool about that is it's just text, so you can use pipes on the shell to play around with it. So for example, if we want to write out this file to a bundle that we can execute, we can pipe that into this other file called, or this other program called Browserify, and then pipe that into a bundle.js. And the bundle.js is just like if we run our code with Browserify directly. It's just got this simple prelude and not much else. And then you can actually run the bundle directly, or you can just drop this into a browser in a single script tag like this, and it'll work. So like that. And if you were to drop that in a browser, it would work. Or I can actually run that, but I won't do that at the moment. So this is basically all that Browserify is doing with a bunch of extra junk on top that you need to run a lot of Node modules. But that's pretty much it. So now that we've got these kinds of primitives where we can really trivially share code between, or not share code so much as we can just take code from NPM that people already wrote for Node and didn't even think about the browser at the time for the most part. And we can make most of that code just work in the browser just fine. So what does that look like? So there's one of these really big ecosystems of packages that's grown up, and it's exploded, and nobody's really taken notice yet, but I think it's really phenomenal, called NdArray. So NdArray is a bunch of libraries for doing n-dimensional matrices, which doesn't sound very interesting until you look at all of the crazy modules that people have written on top of this data format. So let's do something really fun. Let's compute the FFT in Node or the browser using some NdArray modules. So the first thing we'll need to do is require them. Splitting on dashes, that's super weird. Hang on, let me refresh this. This is super weird. There we go, that's much better. I'm just going to leave it like that. Okay, so the first thing is we've got some modules we need to import. The first one is just NdArray that lets us create NdArrays. But what's cool about NdArrays is that most of the time you don't actually deal in the NdArray objects themselves. You deal with typed arrays, which are native in the browser, and you pass those around, and only when you actually need what NdArray provides do you put them into an NdArray, which is a kind of strided array. It's a little bit technical, but then you get to go candy store and pick all of these great pieces out. So there's a module for doing the FFTs, there's a module for computing magnitudes. So the next thing we need to do is actually use a float32 array, which is a browser built-in that's available. And so now we can compute a function. In this case, we'll have two sine waves that will sum together. One sine wave will operate at 440 hertz, and the other operates at 2000 hertz. And so if we run an FFT on this data signal, we should get spikes at approximately 220, or 440 and 2000, I mean to say. So the next thing we need to do is pack that data, pack the outputs from the function into our data array, like that. And then we can actually call the NdArray module. So here we're calling the NdArray with data, and another float32 array to store the imaginary components of the FFT. Once you do all of that, you make just a few function calls with the modules. In this case, we want to compute the FFT and then the magnitude. Once you've done that, then you can actually get out the result. So here is each of the real components that are left over. We can reverse engineer the frequency back out of that just by multiplying back the rate. And then we can just check for where the spikes are. So if we run this program in Node, huzzah, we get a spike at 440 hertz and 2002 hertz, which is pretty good. And those are the amplitudes at the right, which is not as important. So that's really cool. And I'm going to get back to this example later because we'll run it in the browser and do some visualizations. But first, let's do some Webgl. So there's this other part that's kind of grown off of ND arrays that's really nascent at the moment, of doing Webgl with very, very tiny, really powerful NPM modules. So there's a module, for example, called Bunny. So let's do some Webgl with tiny modules. So first of all, require Bunny. And then we can create a mesh viewer, which is another NPM module you can install that just renders meshes. And do some setup by creating the mesh, and then draw the mesh. And that's it. So it only takes this small amount of code to create a sweet little bunny visualization. So we can click on that. Hopefully it'll work on this computer. Yes, it does. Very good. Okay. There we go. There's a bunny. And you can twist it around and all kinds of stuff. You can pan. So that's really cool. Not only was this a really small amount of code, but it's actually really powerful because you get all of the primitives, and there are a lot of modules that just do one very narrow thing that's pretty incredible. So instead of depending on something like 3JS that has reasonable defaults, but you start hitting a wall as soon as you want to do something a little bit extra. If you go with this approach, it's a bit harder at first, but you can do all kinds of crazy things. So here's a crazy thing. This is an isosurface. So similar to the FFT example, we can actually procedurally generate an isosurface using a bunch of tiny modules and Webgl for a complex 3D terrain. So there's some other modules like GLNow and GameShell that set up some basic primitives that you might want in a scene, like cameras and the Webgl context, which is kind of a lot of boilerplate code. So you can use these modules. Now we can just set up the basic camera and scene parameters and set up a rendering. And that's pretty much all the boilerplate that you need. So here we've got just a simple matrix, simple perspective projection. If we wanted, for example, an orthogonal projection, that's easy to do as well. So once we've done all of that, now we can do the crazy part. So here is a function, f, that gets parameters x, y, z, and returns this really nasty function here that has sine waves and cosines and more sines and all kinds of terms inside of each other. So that will look really cool when we graph it as a solid, as an isosurface. So there's one more thing that we had to do then. After we have that f function, we need to import some other modules. This one is a Simplicio complex module. I'm not even sure what that is. It has something to do with this, which is a module. Isosurface is the module that lets you basically make shells out of functions. So that's all you need to do. And then at the very end, we just call mesh.draw. And then, just for a little bit of more fun, suppose we also want to see the axes, because that's a really handy thing to have when you're graphing functions. So you can import another module called GL axes, and that gives us a little create axes function that we can use. Oops. So then you just create the axes and you draw them. And that is pretty much all that it takes to make this. Just have to give it a moment. It takes a while to load because it's very CPU intensive. Oh, this was the coolest one. No. Okay. Let's try that again. Some of these files have obscene dependency graphs, but it's great because they all still work because all of the modules keep to themselves. So there we go. Oh, okay, well this module isn't working. It is the coolest one, but look at it online later. I'll post a working example. Maybe we'll get lucky with that. Anyways, so for the next thing we can do, there's a whole other little niche ecosystem that is really fun, that involves hundreds of modules, called, well, it's not really called anything, it just has to do with music, making music, particularly procedural music from algorithms. So what does algorithmic music look like? You might ask. Well, let's write a song. Okay, so to write an algorithmic song, in this case, we've got to satisfy this function signature where we get the time t in seconds, and we should return a value between -1 and 1. That will be the amplitude. So a really simple thing to do is just have a sine wave. So we can have sine wave of 2 times pi times t times the frequency that we want to hear. So if we want a sine wave at 440 hertz, which is about middle A, we can just do that and then run it with this program you can install with NPM called Audio. And it's making that noise. There we go, I'll kill it. So it doesn't sound too great, but we can start playing with it a little more and make it actually sound kind of cool without that much work. So the first thing we should do is factor out this part into its own sine function. So you can take the math.sine of this and make 440 parameter to this function. Okay, so now we can just return sine of 440. And if we want to like have it go whoa, 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 we can sine of 1 will pulse once a second, for example. So we can play that. Oh, it sounds kind of really crappy. Anyways, so basically just using simple tricks like that, we can make more complicated songs. Hang on. I don't know what happened to the shell. Let me refresh that page. Anyways, I'll use this shell to show you that. So, wow, that really messes up. Here we go, I'll just show you like this. So basically, here is just this pretty simple algorithm that just uses simple functions, and using a bunch of NPM modules, now we can play it. So anyways, you can do that. But there's more. So what else can we do using this kind of approach? You can do a lot. Right, and now this one crashed. Goodness. There we go. Okay, so wouldn't it be great if we can play algorithmic music, if we could actually visualize what we're doing so we can have more insight into what the amplitudes are, what the frequencies are that we're dealing with. So great, let's do that. Using some of the things that I've already shown, we can do that. So here we're using a module called Amplitude Viewer, which basically just is a little, it's a little module that uses SVG elements and to basically graph functions. So here is the source code to this whole module. So basically, we're using a transform that lets fs.readFileSync calls work, called brfs, and then we're just loading a bunch of modules. So here's one that turns HTML strings into DOM elements, one that does inheritance, one that does kind of like positioning and visibility stuff, and just a simple constructor, and then what? And that's pretty much all that it takes. So to use that module, all that we've got to do is just require it and append it to the DOM, and then on an interval, just draw, in this case, this function. So what does that look like? Here we go. So now we're drawing the superposition of two sine waves. So basically, they kind of go together, and we've even got a scale bar here, so we can adjust what we're looking at. And we can zoom out really far. It looks pretty cool. If you pause it, then this does something, but right now it just pans, but it's kind of hard to control. Okay, how did I get? Not sure where the other. Okay, cool. There it is. Great. So that's fun. What else? So there's also, that was amplitude. How about frequency? We can do frequency too, and it's pretty similar. So just like before with the FFT stuff, we can populate a data float32 array and pass that into a module, frequency viewer, that will do the ND array FFT code for us. In this case, we're running it in the browser. So what does that look like? In this case, we're taking the same function that we showed before with the 440 plus 2000, the two sine waves, and that looks like this. So we have a zoom control here at the side too. So basically, the one on the left is the 440, and the one on the right is the 2000. And then there's also kind of some noisy harmonics there at the bottom that we can zoom in on. You see it's running live. They're slowly bubbling up and down surrounding areas. So that's pretty cool. But what else can we do with this? So if we combine all of these pieces together, playing the audio, drawing the components, then we can do something really cool where we basically just stitch the pieces together. I guess I can't show that. We just stitch the pieces together, and it doesn't take that much code. It's all fairly simple, straightforward code, just a little bit of DOM, a little bit of loading some modules, and then we get this, which is not running. One moment. So this thing is called Code Music Studio. There we are. So this one now is running in this computer's browser because it's actually rendering in the web context. So here we've got some basic controls. If we modify the file live, then we can make piercing sounds. What's fun is you can just take some simple effects, like if you have two sine waves that are about pretty close to each other, they'll pulse based on the difference of their frequencies. Or you can do fun things like that. You could also multiply by sine waves, which is fun. Or, if you want to get really fun with it, I'll pause that for a second. We can take some code. Let me think here. How to actually get this code into this computer. So we can also take code that, like I showed, the one that I showed before, where it was an actual song. Because I don't have to do that. Anyways, what else is crazy? Like, what kinds of other ecosystems are really exploding right now that I think are really incredible? One of them is called LevelDB. I don't know if any of you have used it before, but it's basically it's the most Node-inspired database, because instead of having a database service that you run, Level runs in your process, and instead of depending on the database to give you a bunch of features like baked-in GIS support, baked-in all kinds of other things, baked-in querying, Level gives you a very small number of primitives and then expects you to use packages that have been written completely outside of Level in the community. So just for something really simple, so here I have a data.json that just has some simple JSON in it. We have some puts, some keys. So basically this is just some users and some repositories and who the authors are. So it's really simple, kind of like relational style data. But the best part is that all you have to do to install LevelDB is do npm install level. And then instead of it being some service that you run, it's actually just in Node modules like any other module. And to use it, you just require level. So var level equals require level, create a DB handle like this. So test.db. And now we can populate that test.db by doing a batch with that data, like so. So once we run this, we'll have a database to play with. And now we do, cool. So now if I require level from the REPL and give it test.db as the reference, should probably save that to a handle. Okay, cool. So now we have this DB handle that we can call create read stream on. So if we want to get a list of all of the users, give it a start of user and an end of that. And then the cool thing is, not only does LevelDB use npm for all of its features, but it uses core Node idioms like streams. So you can just register a data listener, print out all the results. Here we go. So here are all of the users: Dominic Tarr, Max Ogden, Substack, Nicole Lysenko. And if we wanted to get other information, like the repositories, we could do that as well. The really great thing about this is it's really easy to roll your own kinds of indexing, and it's really easy to inject this into processes. So that code studio that I showed you before is living on studio.substack.net, and I just threw up a quick LevelDB, and I just threw it on my web server, and so it has a really simple database. People can save things. It's really has a really low barrier to entry, so it's great for experimentation. And this database is really cool. This is something that I built when I was in China for a talk I gave there. So we can create a DB handle like before from this placename.db. And this one is really cool because we can create a read stream. So placename is indexed by this big text file called cities 1000. That's all of the cities on planet Earth with more than 1,000 people in them. And most of them include the latitude and longitude. So you can create a basic geocoder with that kind of information. So if we create a read stream where we give it a start of a place name, like we could give it a start of Buddha P, an end of, and everything that starts with Buddha P basically, and listen for all of the records on that. There we go. So here we have Budapest, and it's giving us an integer, which is the primary record. So these are just indexed records. If we want to actually get what the primary value is, then we can get that one. So it looks like 3054643, and we'll just print out the results. There we go. And we've got the latitude, the longitude, some country code information, population even. That's really cool. And populating that database was very straightforward. I did that in, I think, a few hours. It was really easy to do once I had the data. And people have written so many great modules for that. Another one that I want to mention just really quickly is called voxel.js. This is an ecosystem of packages that is built out of very tiny components. So here is an entire, basically, Minecraft game. But you can't really see because the terminal is bugging out. But this is basically 40 lines or so. And what we've done in this file is we've created a Minecraft valley. We've placed a bunch of spiders in it, and the spiders are programmed to follow us. So there are 20 spiders right here, and each spider every second is programmed to notice us, look at us, and then jump at us. So what does that look like? There they are. Ah! We can jump. We can jump, but so can they. They can jump quite high, I guess. I think it's dependent on the frame rate. This computer is very good. So it only took that small amount of code to build these crazy spiders. And that's because there are like megabytes of code doing all of the hard parts. But each of those parts only focused in on doing a really small, specific thing, and just doing that, and not focusing on trying to do everything. And what's great about that is, like, dozens of people worked on different parts of this whole application, and they didn't have to really coordinate very much ahead of time to do that, because they were all just building simple interfaces that don't really depend very deeply on one another. So, here's another thing that I'm working on at the moment, where it's just a simple streaming HTML library. So if we have, so I'm trying to build an ecosystem around this thing. I've already got about 6 or 7 modules. Basically, if you have HTML code like this, and you want to do query selectors on that, you can do that in the browser very easily because those are built in. You can use document.querySelector, but on the server it's more difficult. You don't really want to construct a DOM because that's very heavy and that takes a lot of memory and it's very slow. So you can do this other trick. So I've recently written this module called HTML select, and HTML select takes a selector. So in this case, we can select, I believe there are DT elements in here, and pipe in, well, the first thing is there's this module I wrote called HTML tokenize that takes as input a file and outputs this JSON format, because HTML is really tricky to parse properly. So this one basically flattens HTML, and then other modules can basically be stitched into the pipeline, a lot like I was showing earlier with module deps and BrowserPack. So here we can just do HTML select and select the basic element from it, like that. So basically, I'm doing a rewrite of Trumpet in the same way that I rewrote Browserify because it was getting very complicated. And this way is much simpler, so Trumpet has to worry about much less because the modules do their one thing very well, and everything can become much simpler, and hopefully I can eliminate a lot of bugs by doing this. Very quickly, the last thing I have is just doing, so at scale, how can this possibly work? How can I have 300, how can these people have 300, 500 modules? There are a lot of tools that make that happen. Git is just one of them, but having really solid unit testing and code coverage tools and that kind of stuff is really important for that purpose too. So I'm going to just really fast show how I normally do testing for my modules. So normally I have first the index.js, so we'll make that something silly. This will just be a simple function that maybe asynchronously okay, I don't know why it stopped. Let me refresh that. Uh-oh. Okay, one moment. There we are. Very good. Excellent. Okay, so as I was saying, I usually have just, here I'll just make a simple function that takes an argument and a callback, and that's weird. Well, anyways, if we can't do that, then that's okay. But so we'll just call the callback with null and n times 100. That should be simple. And normally I just have a test directory. And in the test directory, I've got like let's call it test.js. So I like really simple testing libraries. This one I wrote is called tape. It's basically a copy of this other one that Isaac Schluter wrote, author of NPM, called tap. it's not working right now. Anyways, I can skip this. Having tests, super important. You can look at that up for yourself, I guess. So anyways, the other great thing about doing open source at this kind of like big scale is that people like start an issue and like start collaborating and iterating on the features without even you having to be involved. So here's one of the modules that I have. Somebody posted an issue about how a particular feature seems like really necessary because it's very hard to do outside of the module. And then another person chipped in with some suggestions, and like people are going back and forth worrying about like compatibility and things like that. And then in the other post, they were actually like trading patches. Like one person made the first patch and then another one chipped into it. And I think that's really great because nobody like coordinated that. It just sort of happened by itself because we had a public forum where people were like had the power to push changes and see what people thought of them. So this is I think a new kind of model that hasn't really been explored as much, except maybe in open source. And like Dominic said earlier, if you see a job that needs doing, it's your job. And that's something that I wish that people did more of. And I tried to do this. I probably don't do it as much as I could, but it's really fun, and you make a lot of friends. And you get to go to Hungary or whatever other country is the equivalent from here. So thank you.